let's start with the problem. The majority of AI agents today hallucinate, fail to productionalize, and fail to scale. And the root cause is the same. They don't have context about your business data. That's exactly the problem Intugle solves. It generates a semantic layer, an intermediate intelligence layer on top of your data that AI agents can leverage to actually understand what your data means. So today, I'm going to show you how to build that semantic layer from scratch. We'll go from a zero to a fully profiled, linked, and business-ready data model, all without writing a single line of code. Let's get into it. So first, let's create a workspace. Let's head over here and create workspace. Let's give your workspace a name. Now, a workspace is a container for all your data apps, your chatbots. So, I will be working on the life sciences data domain. This will be the data I'll be working on. So, I will just give it a name, life sciences. Let's go ahead and create it. So, the first thing we do is connect to our data sources. The life sciences data is spread across multiple databases, a Postgres database and a Snowflake warehouse. So Intugle supports several connectors out of the box, and you can set up multiple connections, and Intugle will federate between them seamlessly. So let's go ahead and click PostgreSQL here, and let's give it a name for our connection. So this will be life sciences G, and here you can enter your connection details. Now, the same connector can be used for connecting to a NeonDB or a Superbase as well. So I'll just enter the details. Okay, so I've just entered the details. Let's create and continue. So Intugle will verify the connection right now. So once connected, it pulls up the full list of schemas and tables available in the database. So if you come here, you can see that this is the data that I need. And let's go ahead and select all the tables that we need to run our AI pipeline. So I will be selecting all of these. All right. All right, so now we can save the connections with all our tables. So in a very similar fashion, we can go ahead and choose our next source. So I will be going ahead and setting up my Snowflake connection. So I've just set up my Snowflake connection as well. And now let's go ahead and continue building our semantic graph. So we can hit the button here. And this launches the AI pipeline. Here's one of the things I love about Intugle. You don't have to sit and wait. While the AI agents are doing their work in the background, I can start enriching the model with business context. So first on the left, let's select our industry vertical. In this case, I'll select life sciences. So let's go to others and let's type in life sciences. All right, now this matters because the AI uses this as a signal to generate more relevant industry appropriate business glossaries. All right, so next, here's something important. My data is actually coming from SAP ERP and Oracle JD Edwards tables. So the table names are transaction codes. They're not human readable. In order for the AI to generate accurate business glossaries, we need to give it some reference material. That's where web domains come in. So I will add two websites and this one. All right. So these are ERP reference sites that document what these T codes actually mean. Now, by providing these domains, you're telling the AI to generate glossaries from sources you trust, not just generic definitions pulled out of thin air. You can also upload any document containing glossary definitions, say your company's internal wiki or a data dictionary. That's another option if you have proprietary terminology. So meanwhile, you can see on the right, our data is getting profiled. The AI agents are running behind the scenes to understand your data better. All right, now let's go ahead and click continue. Now let's talk about domain classification. This is where I organize my tables into logical business areas like inventory, sales, finance, or customer. The magic here is that I don't have to tag every single table. I just tag a few tables as an example, and the AI agent takes it from there. So let me go ahead and create a few domains and tag a few tables. I'll create inventory, customer, product, and let me go ahead and tag a few. So I can tag the tables from here. So let me tag this one and this one. I'll be tagging this one here. All right, so that's how you can tag a couple of tables to domains. Let me add some more domains and tag a couple more tables. So I've just added a couple more domains here and I've tagged a couple more tables. So let's go ahead and click continue. Now, in case you want to skip this step, you can go ahead and click skip right here, but let's click continue. And then the AI agent will take it from there. It intelligently classifies remaining tables based on the patterns it learns from the ones I've tagged. So on the right, you can see it trying to group all of these. We'll give it a moment for it to tag. Yep, and as you can see, we have all the tables tagged to all of the domains that we had mentioned. And note that we only tagged like a couple of tables. The rest of it intelligently figured it out. Great, let's move on. All right, now on the left, you can see that the data profiling step just has finished. So let's take a quick look at these metrics. So instantly, Intugle has analyzed our data set. We can see it automatically separated our columns into 222 dimensions and 32 measures. It also breaks down the data types, identifying text, integer, float, datetime, and more. And we also get an immediate read on the data quality as well. We have 98% completeness and 30% uniqueness. So it gives us an overall health score of fair. So this gives us a clear picture of our data's reliability right out of the gate. Cool. Right, so now, as you can see on the top right, we have a status bar explaining what is going on, what current step is going on. We can see that all of these other steps have already been completed, and now relationship identification is currently going on. So let me give you a brief breakdown of how these steps actually work. So in data profiling, the agents scan every selected table and column, counting records, separating dimensions measures, identifying data types like text or integer, and measuring data quality metrics like completeness and uniqueness. You get a complete health check on your data, and it predicts the semantic type as well. Is this column really an integer, a date, a string? And importantly, is it a dimension, something you group by, or a measure, something you aggregate? Next is business glossary generation. For every table and column, the agents generate a human readable business definition. These are grounded in the industry and web context you provided earlier, so they actually make sense to a business user and not just a database admin. Then there's key identification. The agent identifies primary keys and unique identifiers within each table. And finally, we have relationship prediction or link discovery. Now, this isn't just a naive column name match. The agents run multiple guardrail checks. They verify that the linked columns follow similar data types. They ensure a high number of values actually match between both columns, so the link is genuinely present. And they determine the cardinality of each relationship based on uniqueness. That means they only produce one-to-one or one-to-many relationships, never many-to-many. So it keeps your graph clean and accurate. So we will give it a couple more minutes for the link prediction to finish as well, and then we will explore the graph. And the pipeline is finished, and let's start exploring the graph. So we can see all these tables here, and if you right click a table, which is this central piece here, you can see the business glossary that was generated for that table. And you can also view a sample data from that table as well. Cool. Now, all of these other smaller nodes are the columns for that table. So you can see that those columns are attached to this particular table. So if you right click that particular node, now you can see the properties for that particular column. So this column is an integer column, and you can see the glossary that was generated for this column, the tags that were generated, and we can see what was the count, what was the percentage of non-null values, and its uniqueness, the distinct values percentage. We can also preview the data that is in, preview the data for these columns. Great. So that's how you can explore different columns and tables and uh, see what the glossaries were generated, what data types were generated. You can also get a nice tabular view if you click this particular icon right here. So as you can see, all that data that we explored in the graph, we can see it here in a nice tabular fashion. All right, let's head back. You can also see that there are several edges going from a node to another node, a table to another node. These are the different relationships that were identified. So let's explore what that looks like. So if you right click a particular edge, you can get all the details about that relationship. So as you can see, this is the source, this is the target. We have a relationship going from this particular column of this table to this particular column of this table. Now, let me explain what these two mapped values mean. Now, 100% mapping means all the values of this particular column 100% overlapped with the values of this target column. And meanwhile, in the target column, only half of the values had an overlap with this column. Now, what that signifies is that the target value is the primary key in this case. Now, these are individual metrics of each of those columns. So these metrics really help us validate if this is a real relationship or not. Let me also show you the granularity slider on the left. So right now it's at a column level view. You can drag it up to see a table level view. So now you have a cleaner graph where you only see the tables and the domains. And you can also pull it back to see the domain level view where you only see the domain. You have a search bar on the top as well where you can filter out various tables or columns. So you can see that it highlights exactly what you search for. And you can also filter it out by the domains. So as you can see, we can filter it out by the domains as well as the tables inside each of these domains. And finally, notice the agent at the bottom. It's ready to chat. All the intelligence that was just generated, the profiling, the glossaries, the relationships, it can now be utilized by an AI agent. And that's the power of this semantic graph. So that's it. In just a few minutes, we went from a raw database, Postgres and Snowflake, to a fully enriched semantic data graph, complete with profiling metrics, intelligent business glossaries, domain classifications, and discovered relationships. No manual mapping, no writing SQL, no back and forth with your data team. And that's how easy it is to generate a semantic data graph on your data. So in the next video, we'll dive into how you can actually interact with this semantic data graph, querying it, searching it, and using it to build data products and data apps. So if you found this useful, make sure to subscribe to Intugle, and we'll see you in the next one.